Good morning, everybody. Today we're going to do a lab with work. We're going to do the work, and so is the inclined plane we're going to use. We're going to see the difference between the work that we do and the work that the inclined plane does. So if you've printed out your copy of the lab handout, you'll notice that we're going to use a CPO ramp, and I've got a box with some heavy masses in it that we're going to do work to pull up the ramp, okay? And we're going to be measuring the force exerted by me to lift it up the ramp using a Newton scale. That means I won't have to use as much force as the ramp. The ramp will lift the entire weight up to the height that we want, and over a short distance, but I have to use less force over a longer distance. And we can calculate the work done by the ramp and the work that I do, and we can compare them. We can see what is the efficiency of the ramp and what is the mechanical advantage. The interesting little twist we're going to put in it is we're going to do it for 3 different angles to see if the angle we use makes a difference for the amount of work we put in versus what we get out. Does that affect the efficiency and the mechanical advantage? Let's see. Okay. All right, so I've already taken some measurements to save a little time. For example, I already found the mass of the box and I added the masses that were inside, so the total amount of mass that we're going to pull up the ramp is 1.65 kilograms. 1.65 kilograms. So you need to write that down as the mass we're doing work on. Now we're going to do the work for 3 angles. I'm going to call them angle 1, which is small. That's what it's set up for now. Angle 2, which is a medium angle. And angle 3, which is a large angle. I've also already measured the distance that I will pull the box and masses along the ramp. It's going to be pulled 0.725 meters along the ramp each time. But the vertical distance will be different depending on the angle used. So we will have to measure the initial and final heights and find the vertical distance from those. And then we'll also measure the force I put in, and then we can calculate the weight of the mass, which is what the what force the inclined plane puts out. Okay? All right, now I have a meter stick, and I'm going to use it to measure the initial and final heights of the box of masses, so that as I pull it up the ramp, we can see the vertical distance that the ramp lifts it through. So the initial height right here would be 13.5 centimeters, which is 1.35 meters. And I'm going to write that down. You can, yeah. The vertical displacement is going to be the final height minus the initial. And we just said the initial, whoops, that's supposed to be a minus, is going to be 0.135 meters. It's 13.5 centimeters, but 0.135 meters. Now let's get the final height. The final height is going to be right here where I have it marked. And for the final height, I'm getting 33.0 centimeters, which would be 0.330 meters. So we say 0.330 meters for the final height. So the vertical distance that the ramp is going to lift the mass through is the difference between those 2 heights. So if I use my calculator, I can say 0.330 minus 0.135, and I get an answer of 0.195 meters for the vertical distance for this trial 1, for this smaller angle. So 0.195 meters is the vertical height through which the box will be lifted by the ramp. But in order to do that, I have to pull it 0.75 meters along the ramp and measure how much force I exert doing that. How much force do I put in over this longer distance on the ramp? So we're going to set our box up here. Now I'm going to pull it up the ramp and read how many newtons of force I have to exert to lift it. Whoops.
Go.
Sorry about that. I'm clumsy here. All right, so how much force do I have to use to lift it up the incline? I'm just going to have to watch it, make sure it doesn't tip. Okay, so if I'm looking, I am using 8.5 newtons of force along the ramp to lift it all the way up to that height right there. Now I'm at that height. So yes, I used a longer distance with a force of 8.5 newtons, but the ramp used a larger force equal to the weight of all this over a shorter distance. Okay? So let's take a look. All right.
Go.
Okay, so I used 8.5 newtons of force to pull it this distance along the incline. But the weight of the mass would be m times the acceleration in free fall. So over here, I'm going to say the weight equals m times the acceleration due to gravity. So that's going to be 0.195 times 9.8 meters per second squared. Now I'm just doing this one for you as an example. You'll be doing the others yourself. 0.195 times 9.8 equals 1.911. And since we have 3 sig figs, we'll just say 1.91. That's fine. Newtons of weight. So we come back over here, 0.19, oops, sorry. Let me fix that. All right, that's 1.91 newtons of force that the mass lifts over that vertical distance. So I used something's not right. Pause it. Okay, guys, I had to pause it because I realized I made a mistake. This is not the mass that we're trying to find the weight. This is the vertical distance. I just looked over and grabbed the wrong number with my eyes. So I had to go back and recalculate the weight of our mass. Here's the mass multiplied by the acceleration in free fall. And actually we get 16.2 newtons that the incline puts out for us. That's the force the incline uses. So over here, we're going to put 16.2 newtons of force put out by the incline. Okay? Now, there we go. That's a little bit better, isn't it? All right? Now, since our masses are going to stay the same for all 3 trials, so will the weights. So we can reiterate those numbers, that means write them again, in the same place down the column. Okay? All right, now we're going to change to a different angle, and then we're going to go to the medium angle, and we're going to measure how much force it takes for us to pull it up and the new vertical distance that the incline plane lifts the mass through. Okay? Pause. All right, everybody. I have now moved it from right here to right here. So it's steeper and it'll end up at a higher location. Now to save time on this video, I've already measured the new initial height and the new final height. And if you'll bring the camera in, we can see The new vertical displacement that the incline is going to pull it through is 0.287 meters. So if we go over here to our paper, on the second trial, the medium angle, the new vertical distance the incline will lift it to is 0.287 meters. Okay? Now, all I have to do is take my Newton scale, and let's see if we can keep it from falling off one side or the other, and pull it straight up the ramp and read how much force I'm exerting. Oh, look, I'm exerting about 10.5 newtons up the ramp. That's actually pretty good. Okay, I don't think I have to go all the way, but I will anyway. There we go. There's the final height right there. Okay, so I did the work, and I used 10.5 newtons of force. That's what I put into the job. Okay? All right. Now, let's change the angle and do this again. I'm going to change the angle to the third angle. All right, so now I have changed it from this hole to this hole, so it's even steeper than it was before, the largest angle. So for this trial, I already took the initial height and the final height so we can see the overall vertical displacement that the incline will lift the mass through. So I got 0.570 meters for the final, 0.200 for the initial, and here's the important part. The vertical displacement for this largest angle is 0.370 meters. So we're going to go over here and put it right here, 0.370 meters. Okay, now the only thing I need to get is the force that I have to exert to pull it up the incline along that distance of the incline. So here we go, and hopefully we can keep it from falling. This one's going to be a little tougher. All right. Oh my goodness. There we go. We got it started. All right, and I am getting, ooh, look at that. I'm getting 12 on the nose. All the way up to the top. Boom. There it is. And so it's gone through the vertical height from the incline, but I used 12 newtons of force along the ramp. So let's come over here. And the force I put in was 12 newtons. And the force that the incline put in was 16.2 newtons. So I used less force over a longer distance, whereas the incline used more force over a shorter distance. That's the advantage of using a simple machine like an incline plane. You use less force over a longer distance, whereas the incline will use more force over a shorter distance. Okay? All right, so now that you have the data, right below the data table, you will see the instructions for the calculations. For the first one, we've actually already done it. The first one says to calculate the force that the incline puts out for us. And that's the weight of the mass being lifted from one height to the other. And we found that already. It was 16.2 newtons, the weight of the combined mass. Now, calculation number 2, you're going to use the force exerted by the incline, the force put out, times the vertical distance over which the incline lifted the object to get the work that the incline is doing. You can put your answer for each trial in the table on the back of the page. There is a column for the work that that the incline plane puts out. You just take the force out and multiply by the vertical displacement. That gives you the work out. Then on calculation 3, you're going to determine the work that you put in to pulling it up to the new height. So you use the force we exerted, the force in, times the distance along the ramp. And that will get you the work that you put in. Now, once you get the work in and the work out, and of course you also know the force in and the force out, you can find the efficiency and the mechanical advantage on the analysis. Then I want you to find the answers to, or write the answers to the questions. And that's all there is to the lab. So, do a good job. Bye-bye.